All right, today we're going to tackle a classic coding problem that's all about one thing: efficiency. Now, it looks pretty simple on the surface, but the solution? It's surprisingly clever.
So here's the puzzle at the heart of it all. You've got two lists. They're already sorted, and your job is to merge them into one. But here's the catch, and it's a big one. You can't use any extra space. You can't just create a new third list to dump everything into. Nope. You've got to solve it with only what you've been given.
So let's get specific here. Our goal is to take everything from the second array, nums2, and merge it perfectly into the first array, nums1. At the end, nums1 needs to hold the entire single sorted result.
Okay, let's look at a real example. We start with these two arrays. You can see nums1 has its own sorted numbers, plus some empty space at the end. Those zeros are basically just placeholders for now. And then we have nums2, our other sorted array. The mission is to end up with that final, perfectly sorted version of nums1 you see on the right.
Let's be crystal clear on the rules of the game. First, both arrays we start with are already sorted. Second, the final result must be stored inside nums1. And third, this is critical, nums1 has been set up with just enough empty space at the end to hold all the numbers from nums2.
Now, this in-place requirement, having to modify the original array directly without creating a new one, that's what makes this whole problem so tricky. The most obvious approach, the one everyone thinks of first, seems simple, but it hits a major roadblock. Let's walk through why.
So naturally, what's your first instinct? Well, you probably want to start right at the beginning, right? We'd look at the first number in nums1, which is 1, and compare it to the first number in nums2, which is 2. Okay, so 1 is smaller than 2, so it stays right where it is. Easy peasy. Now we just move on to the next comparison, the second number in nums1 against that first number in nums2,
and boom, here's where it all falls apart. To place the 2 from nums2 into nums1 in the correct spot, we'd have to overwrite the existing 2 that's already there. We literally just destroyed a piece of data we still need to process later on. This approach? Yeah, it's a total dead end.
Okay, so starting from the front is a no-go. What now? Well, this leads us to that beautiful aha moment, the key to the whole puzzle.
The trick? You just flip the entire problem on its head. Instead of starting from the beginning, you guessed it, we start from the end.
And why on earth does that work? Well, think about it. Where's all that empty safe space we can write our answers to? It's at the end of nums1. So if we compare the biggest numbers from each list first, we can fill in that space from right to left, and we never ever risk overwriting a number we haven't looked at yet.
Okay, theory is great, but let's actually see this in action. We're going to walk through our example step by step and watch the magic happen.
So to keep track of everything, we're going to use 3 pointers. Just think of them like little bookmarks. I starts at the end of the actual numbers in nums1, J is at the very end of nums2, and Z, that's our writer. It starts at the very last empty spot in nums1, right where our biggest number is going to land. Okay, first comparison. We look at the numbers our I and J bookmarks are pointing to, a 3 and a 6. Which one's bigger? The 6 from nums2 is the winner. So we pop that 6 into the spot Z is pointing to at the very end of nums1. All right, what's next? We just move our J bookmark and our Z bookmark one step to the left and do it all over again. Compare them. This time it's 3 versus 5. The 5 is bigger, so it gets copied over. See the pattern here? We move our pointers again, but wait, this time things are different. The number at our I bookmark, the 3, is larger than the 2, so that's the one that gets copied over. And since we use the number from nums1, we move the I bookmark to the left this time. And from here, we just keep going. We keep running this simple comparison, filling up that nums1 array from the back to the front. What if they're equal, like these two are? Doesn't matter, we can just pick one. We just keep this rhythm going until every single number from nums2 has found its new home. And just like that, you've got a single, perfectly sorted array. See, that logic is so clean, so effective. Now, the cool part is seeing how this simple idea translates into just a couple of lines of actual code. So the whole engine driving this is just one little loop, this while j greater than 0 thing. All that means is, hey, as long as we still have numbers left in nums2 to deal with, keep on going. And inside that loop, this if statement is the brain of the operation. It's doing exactly what we were just doing by hand. It's asking 2 questions. First,
do we still have numbers to look at in nums1? And second, is the current nums1 number bigger than or equal to the nums2 number?
And based on the answer, the code does exactly what we did. If the answer is yes, it copies the number from nums1. If it's no, it copies from nums2. Then it just scoots the correct pointers over, and the loop runs again. It really is that simple.
Now, the real beauty of this whole backwards approach is just how efficient it is. The fancy term for it is a time complexity of O of m plus n. But all that really means is we only have to look at each number in our lists one time. That's it. So it's incredibly fast.
So let's just recap the magic here. We worked backwards, and by doing that, we created a perfectly sorted list. We did it super efficiently, only touching each item once. And this is the big one. We did it in place, without needing any extra memory at all.
And that really leaves us with a cool thought, doesn't it? This whole elegant solution only came to us when we completely flipped the obvious approach on its head. It really makes you wonder, what other tough problems out there might have a surprisingly simple solution if we just stop for a second and try thinking about them backwards?